Okay, how do we add or subtract rational numbers or fractions? We always need a common denominator. So for example, if I'm doing 1/3 plus 3/4 minus 1/2, the lowest common denominator, what do 3, 4, and 2 all go into? Well, I've got a lowest common denominator of 12. This is kind of a review from elementary school, but to make a lowest common denominator of 12, I need to multiply each of these fractions, top and bottom, by whatever it takes to get that denominator up to 12. So for example, to get 3 to 12, I've got to multiply it by 4. So I've got to do times 4 on the top and bottom. Then same thing for 3/4. To get 4 to 12, I've got to do times 3. So I do it top and bottom, and then times 6 and times 6. So why do I do that? Well, the purpose there is that I've now got a common denominator of 12, and on the top, I have 1 times 4 is 4, plus 3 times 3 is 9, minus 1 times 6 is 6. After that, I can just keep my denominator at 12. 4 plus 9 is 13. Take away 6 is 7. So that's how we add or subtract fractions. They need a common denominator. And we're going to follow that same approach now that we're working with rational expressions, with expressions that have variables in the denominator. So here's our first example of a rational expression. I'm going to start the same way. I'm going to think of, well, what's my lowest common denominator? Well, 8, 4, and 6 all go into 24, and then x squared, x, and x cubed all go into x cubed, right? That's kind of the minimum number of x's I need for my common denominator. And we're going to kind of think the same way. What do I need to multiply everything by to get up to this common denominator? So I want to rewrite this fraction as over 24x cubed. So to get 8x cubed up there, I need to multiply it by 3x. And I also need to multiply 3 by 3x. So I'm going to have 9x. What does 4x need to be multiplied for? Well, I need to multiply it by 6 to get to 24, and then by x squared to get to x cubed. And then same thing on the top. So I'm going to have 1 times 6x squared. So it's going to be plus, let me use my pen, plus 6x squared. What do I need to multiply 6x cubed by? Well, just 4. So I've got to multiply negative 5 also by 4. So I have minus 20. And that's it. I can look on the top to see if I can take out a common factor, to see if I can simplify or collect like terms. I can't in this case. So that's as good as I can do in terms of adding and subtracting for this rational expression. We just want to make sure, as always, that we state restrictions. What can't x be? That would make the denominator equal to 0. Well, it's just 0. So I can say x cannot equal 0. So that's the basic idea of adding and subtracting rational expressions. I need to make sure there's a common denominator before I can add or subtract. We'll just do a couple more examples to see what comes up. So here's another rational expression. Sometimes I think it helps to kind of put brackets around these factors in the denominator. You can think of each of these as a sole factor. So my lowest common denominator would be those two multiplied together. So the lowest common denominator of 2n plus 1 and n minus 3 is just going to be 2n plus 1 times n minus 3. Our LCD is always going to be the product of all the unique factors. So to get this common denominator on my first expression, I would need to multiply top and bottom by n minus 3. So I would have 3n times n minus 3. And again, I want to write this whole thing over my LCD, so I'm going to have 2n plus 1, n minus 3. Plus, and then I've got 4. How do I get this second fraction to be over this common denominator? Well, I've got to multiply it by 2n plus 1. So I'm going to have 4 times 2n plus 1. So now I've managed to write this expression over the same denominator. Now I can just expand and simplify and see what we get. So I've got 3n times n is 3n squared, 3n times negative 3, negative 9n. So I've expanded that, and then similarly I've got 8n plus 4 still over this same denominator of 2n plus 1, n minus 3. Now I can just collect like terms, so here's my last step. I've got 3n squared minus n plus 4, 2n plus 1, n minus 3. Now I could look to factor this, but nothing multiplies to positive 12 and adds to negative 1. So I'm done. I can't factor that numerator at all. And again, we just want to state restrictions. What makes each factor equal to 0 on the denominator? So n cannot equal -1/2 or +3. If you're wondering how do I get that -1/2, we learned that shortcut in a previous unit. It's always this second term flipped divided by the coefficient on the first. If you'd rather, you could just set 2n plus 1 equal to 0. That's what it can't equal. When I move the 1 to the left side, then I can just divide by 2. So that's how I get n cannot equal -1/2. So I've stated my restrictions, I've got a common denominator, and I've simplified. We're just going to do one final example. Okay, so in this example, the first thing I'm going to do before I can state my lowest common denominator is I'm going to factor both expressions. So the numerators have nothing to factor, but in the denominator here, I've got a difference of squares. So I have t minus 1, t plus 1, and then I'm subtracting t plus 2. Again, nothing to factor there. I find it helpful to kind of add those brackets around my numerator. Then I've got a simple trinomial, so what multiplies to -4 and adds to +3? Well, I've got +4 and -1. So there's my first step. I'm just factoring both expressions. Now I can find the lowest common denominator. It's going to be the product of all the unique factors. So my lowest common denominator, well, I've got a t minus 1. I don't need to write it twice. It's already shared. I've got a t plus 1 and a t plus 4. So there's my product of unique factors. And I'm going to write this subtraction expression over this common denominator. So that's my goal. That's what I'm trying to do. So this first expression, well, I need to multiply top and bottom by whatever factor is missing from the common denominator. So for the first one, I need to multiply top by t plus 4 and bottom by t plus 4. And now it's over the common denominator. So I can write that as 2t times t plus 4. Same thing for my second expression. The missing factor here, well, what's missing from the LCD? Well, it's that t plus 1. So I'm going to multiply top and bottom by t plus 1. So I'm subtracting t plus 2 times t plus 1. So again, before we can write it over the common denominator, I need to make sure I'm multiplying top and bottom by whatever is missing. And the same way we did it with fractions in elementary school, now we're doing with rational expressions. So now I can just expand and simplify the numerator. So I've got 2t squared plus 8t. And then I'm just going to leave that -1 out front and FOIL or expand these two binomials. So I've got t squared plus 2t plus 1t is 3t, and then plus 2. And each step, I've just got to make sure that I keep this denominator. There's nothing really to do with my denominator because it's already fully factored. And then I'm just going to distribute that -1 in my next step. So I've got 2t squared. Let me just shift this up the page. Plus 8t minus t squared minus 3t minus 2. And it's all over the same denominator. And now I can kind of collect like terms in my numerator. So I've got t squared plus 5t minus 2. And I could try to factor that numerator after this, but nothing's going to multiply to -2 and add to +5. So I'm done. There's my simplified expression. And again, I just want to make sure I state restrictions. What can't t equal? Well, it can't equal plus or -1. Those are these two roots on the denominator. And it also can't equal -4. So a little bit of a longer problem. We're going to find our lowest common denominator by taking the product of the unique factors. I'm going to rewrite the expression over that common denominator, and then just expand and simplify and state restrictions. So that's adding and subtracting. Just like when we're dealing with fractions, it's a little bit more time consuming to add and subtract because I need to make sure I have a common denominator, and that same holds true when I'm working with rational expressions. Okay, thanks for watching.